Hello, good day. Thanks for joining me for this video. Today I'll be talking on beams. As you all know, in my previous videos, I've talked about slab and the various things that happens in the software that we might tend to overlook. I hope you find it useful. Now we'll talk about beams. Now for beams, there are so many areas we have to look at the beams from, because right in the software there are so many settings that when you have to check all these settings one by one and compare, it gives you various results, both when you use normal analytical method and finite element method. So for beam, it's a complex case, as you would agree with me that various school of thought exist when it comes to the setting for beam design. For a starter, you have for beam section you have flange and rectangular section, and you also have degree of freedom here, and you have rigid zones. All these things affect the results of your beam analysis and design. But where I will want to start from on beam will be on beam acting as point load. This uh, this case is very important, and as I have noticed in the software over time, in my while testing how the software functions, I have discovered that in a way the software does not see beam acting as point load. What I mean by that is that if you look at this arrangement here, this is a slab panel. This is slab 1, slab 2, and there's a beam that crosses these two slabs that divides it. Now there's a column, and column here. And if you notice that on this side there's no column, and on this side there's no column, and in structural analysis, the assumption is that this beam is supported by this beam on this side, is supported by this beam on this side, which means this beam too, when you check the reaction will be point load on this beam 5, which is what I have idealized here. So this is the beam 5 and this is the beam 2 acting as point load when you check the reaction at both ends for this beam. Now I'm making this assumption before I'm making this sketch so that you will have idea of what I'm talking about by the time we go into the software to check what I'm saying. And we'll be checking beam 18 from our previous model that I modeled in the last video. I will use the same model to show you what I observe when it comes to point load. Now you will agree with me that this is beam 18, which is what I have sketched out here, beam 18, and I have beam 7 on this side that is acting as point load on this beam. So now when the software, I have run the analysis, and this is the results of the analysis, and this is the bending moment, the maximum bending moment that is showing here. Now look carefully, look closely, that the software is saying the bending moment is like this, but at this point there's another showing that there's a variable load that is there. Now if you check it, that load is as a result of the load coming from the slab from this panel on this side, this particular load. So we have load from this slab here, then we have load on this adjacent slab, which means, let me show you. So load coming from this slab onto this beam, and this particular load coming from this slab onto this beam. So that is what this is showing me here, that this is the load from here and this is the load from that portion of that slab that is on this side. So after running the analysis, this is the result that I got from the for the moment. Now when I this is the result I got for the moment. So what I did was that I modeled the same thing in Tekla TED. So this is the loading on the beam, on that particular beam. You can see this is the load from that other slab, which is this slab, this slab, the load coming from it up to this, from this point up to this point. I've modeled exactly from that point up to this point, and I have this same slab having a load coming onto the same beam. So it's coming from this point onto this point, which is what I've modeled here, from this point onto this point. And you can see the bending moment that is giving me that at this point, as a result of this load, I have this bending moment here up to this point, and this is the maximum bending moment, 136.3 for that beam. That is what I'm on. Now in this case, if you see, I've modeled that there's no point load. Now from the result of the from the software, you can see that I have 132 as a bending moment as well, and it's also showing me that there's a bending moment also on this side. Now let's see this particular beam and see the analysis result diagram. We'll have a better feel. Now you can see now from the software, yeah, it's mirrored on the other side. So that particular loading that I'm talking about is coming at this point. So you can see that it has movement here, which is about 75 and 132. So if I check, let's check from here to, I have movement here 65 and 136, which is still, I will say, okay, I agree with the result. Now, mind you, you understand that this is assumed as simply supported. And of course, in the software, there's always a case of fixity, and it will always calculate the bending moment, the fixed end moment, sorry, at the end for that particular beam. So you can see that in this case, the effect of beam 7 is not showing, which is acting as a point load. Let me close this. The effect of this beam 7 is not showing on this beam, which is acting as a point load. That is, if our idealization is like that particular beam, which is this beam 7, by the time we calculate the reaction, and it will be here. Let's say y. Let's say y. Let me use red. So let's say the reaction will be y, which will be acting as a point load on that beam. Now the effect is not showing from this result, and I've tried severally to check from the software if this is taken care of, but I have discovered that it's not always taken care of. And you'll notice that I have similar case here, whereby this beam will be acting as point load on this beam and then on this beam as well. So from the result, you can see that the effect is not showing of this particular beam acting as a point load on this beam, which is what our idealization is supposed to be. Now, Again, I did model that same beam now with the effect of the point load. You can see that the point load is now being affected in this case. Now you can see the bending moment now has increased for that particular beam. So what it means is that you will require, by the time you check the design, you will require more reinforcement. You can see it's giving me 4Y22, Y16, considering the effect of that point load. While in this case, you see that you can see it's only 3Y25. Let's check the area. The area of steel now will be more than, you can see now, the area of steel required and the area of steel provided, which is 1472. This is what is required. Let's see in this case. In this case, you can see now that is 115 that is required, and we now provide 16 in the case that we model the effect of that beam acting as point load on this beam. So this is one thing I've also noticed that the software does not take care of. Now, like I said, I have modeled it. I've run the design also with finite elements, and I noticed that it's same. It doesn't take that effect of this one acting as point load on this. And now, if I go away and do displacement, you agree with me that you can see that the software itself is saying that at this point there's no support on this at this point, both here and here. You can see the response of the structure at this point. So what it means is that by the time we place our reinforcement, we are saying in the arrangement, we'll be saying this beam, let me stop this beam will be supporting this beam at this point. And normally when we idealize, we say that it is acting as point load at that point, so that by the time we calculate for the bending moment, we can provide adequate reinforcement for it. So we can see that the software does not take care of point load where you don't have columns and you have beam that is acting as support for other beam. So this will be your secondary beam, this will be our primary, this will be our primary beam, and this will be our secondary beam in this case. So like I said, I've tried several ways to see if the software actually takes care of this, but I've not found out. And you can see that's why I try and model it with other analysis, like this one, more like manual. You input the loading, then it calculates the bending moment. So you can see I also did the same, considering the effect of the point load. So what should we now do in this case? What it means is that you have to define this beam, the point load on this beam, for you to have that effect. So there are two ways you can do it. Now, one way is to actually go to this beam and say edit member load and compute all the load. When you compute all the load and multiply it with the span of the beam, then you get the reaction at each end. Then you now use, now if you add this and add this will give me about 60 something. Is it up to 60 something? So the reaction at the end of this beam, it is what you now define as point load on this beam to take that effect. Now you have to understand that in the software, if I click on this beam, if I want to define point load, if I say edit member load and I say new load and I say I want to add point load, then maybe you can label it as point load 1. Then you give the reference. The reference is the dimension, the distance from the one end to the where the beam is acting. Now I have to cancel this and cancel this, and let me show you now. Most times in the software, on the horizontal side, on the horizontal plane, your measurement is your beam actually starts from here and ends here on the horizontal, so it's from left to right, while on the vertical it's measured from down to up. So you have the start here and you have the end here. So if you want to define it, you have to now say you click measure and you measure from here up to here. So we have 650 in this case. Now when you have 650, now like I said, two ways you can do it. It's either you add all the loads and calculate the shear force yourself, or you come to the analysis that you have run and check the reaction on that for that beam, that particular beam, and put it as point load for this beam. So in this case now, let's say it's giving us 71 in this software. Now it's giving us 71, but when I calculated it manually, it gave me, I think it's the load was 90 something. Let's look at the defined load on this beam, so you can see dead point load. So I have 96 when I calculated it manually. I have 96. So if that was the 96 I used in this case, but the software is saying 71 in this case. That is all load has been factored. You can see the load combination. So it's 71.23. Now let me now define this 71.23 on that beam. Don't forget 650 is the distance. Measure distance 650. So I will now come to this beam and say edit member load like before, and I will now say new load, this load, then let me say maybe like point load 1, then the reference is 650 mm, so that is 0.65, then the load is what, 71. Now you have to be very careful because that 71 we are getting from that. Let me cancel this again so that I can explain something like that. So this 71 we are getting, you have to remember that it is factored already. So if you want to define it as point load, you have to factor it down, because when you input the point load, the software itself will still factor that point load that you input, will still factor it by 1.4. So it's better you factor it down when you want to input it. 2.33 divided by 1.4, so that gives me 50.8. So let's say 51 approximately. So it is that 51 that I would define as point load for this. Now say new load, point load 1. The reference is now 0.65, then it will now be 51 because the software will still factor that load when it gets to the analysis part. It's even analysis. I say okay, now let's rerun the analysis as we have defined that point load. So I run the analysis again, run, and okay, it will take few moments. So you can see that it is very important, as I've been emphasizing in my previous video, that you check the output of your result that the software is giving you. The software is to automate the process. You are to do the actual engineering. And how do you do that? Is to check the result that you have. Now let's see the result now. Let's use this and let's see. First of all, let's see the shear. Now I have defined the point load on that. Like I said, if I let me go this so that you can see that the software factors that load. You can see now that clicking on this, that the software has factored that load to 71.4. using 1.4 to multiply it. If I click like this, you can see that this is the 51 that I imputed. So the software goes ahead and factor it by 1.4. So if I had used 71, the software will factor it by 1.4, which will increase the load, and you don't want to do that because the more the load is, then the more the moment. Now, so you can see that the load is now 51 in this case. This is unfactored load, this is factored load, you can see. So let's take this away and let's see the result of the moment and see the variation now. Now let's see the moment. Now you can see that the moment has now increased to 153 as against the 130 something that we have, giving the effect of the point load. So you agree with me that it is very important. Now you can see that in this case, like I said, I used 95 when I calculated manually, so I have 169 in this case, which is different from 136. So which is also different in the software. You can see initially I have 130 something now, and now with the effect of the point load, now it is 153. So today's video will not be more than that. Like I said, BIM has so many areas that we have to look at. This is one area that we have looked at today. In my subsequent video, like I've shared before, I will talk more about other things I notice when it comes to BIM design. Again, you do the engineering, the software is to automate the process for you. So use the software to make your work faster, but never neglect the engineering part, which is your own responsibility. Thanks for watching. I'll see you in the next video. Thank you.